Today on Design, Build, and Fix, we're going to show you how to lay out those posts and beams in your basement to keep it as open as possible. This video is more about showing you how to do the layout of the posts and beams than it is about showing you how to draw it in SketchUp. Our next video coming out will definitely show you how to draw it in SketchUp. If you like the content, make sure you click the subscribe button in the lower right hand corner of the screen. And remember, life's about what you can do and it's based on what you know. All right, so let's go learn something. All right, so let's take a look at this chart here. And if you notice there, it says 40 PSI live load, 20 PSI dead load, this one 40 and 10. Here's the difference between a live load and a dead load. A live load is nothing more than a load that can come and go over the life of the structure. And a dead load is going to be one of those loads that has to do with the weight of the house, the structure of the house, for example, drywall, roofing, carpet, flooring, everything like that. So live load is things that can come and go, and dead load is going to be something that has to do with the structure in itself. Now, I almost always go with the 40-20 load because that's going to give you a stiffer load.
Well, we have two options. One option is our beams can run front to back, or our beams can run left and right. The biggest concerns we have to keep in mind is the distance between the posts, which supports the beam. That cannot be more than 8'6", and the distance between the span of the joists that go from the outside wall to the beam cannot be more than 15'6". So our post, the biggest span a post can be, is 8'6", and the span for our joists, which is going to be 15'6". Now we have pre-decided that we are going to use pre-engineered I-joists, which are 9.5 inches tall, and according to the charts that I've seen, 15'6" is the maximum span that those can run. If this was a real design problem, we would have to mathematically calculate and prove that we could get away with 15'6" based on the loads that go onto it, but that's outside of the scope of this project, and we're just going to assume that we're going to use 15'6" for the joists and 8'6" maximum for the posts. All right, so let's assume that we want our floor joists to run front to back this way. The one thing that we have to keep in mind is that we would really want these to be centered. So I'm going to try and hit one centered, and if center works out and it comes right to the front of this, which gives us our last riser, that would be perfect. If we have to shift it a little bit to the left to make it work, or a little bit to the right to make it work, we could do that as long as the distance that the floor joist span is less than 15'6". Now we used a 10-inch wall. You can't use 10 inches here because after 5.5 inches, which is the sill plate which stands on top of the concrete wall, 5'6" is the distance of the sill plate, so you have to subtract 5'6". All right, so right here is where the floor joists start to be unsupported, and you have to go to the left edge of the beam, which is wherever you place it has to be less than 15'6". All right, same thing on this side. You can't say that it's spanning 10 inches in because it's not. It's actually 5.5 because of the sill plate. So the distance from here to the right edge of the beam has to be less than 15'6". So once you've mathematically calculated it and you placed it in the center, if it's less than 15'6", that works out great. If you want to get it so it goes right in front of where you placed your stairs, and this distance is less than 15'6", and that's less than 15'6", you're good to go. If it doesn't work out and one of the spans is more than 15'6", you may have to do another beam through here. So you have two beams running through here, and that might not be advantageous for us. But it could work. You'd have to calculate it and figure it out. So we have a beam that runs through here. Let's just assume that worked. So the distance from the left edge of this beam to the right edge of the next beam cannot be more than 15'6". If that works, we can go ahead and do that because this span has to be less than 15'6" also. So ideally we would like the beam to fall somewhere on our concrete block wall. So hopefully it falls in here somewhere. So if the distance between here is less than 15'6" and from here is less than 15'6", that works, that we can get away with one beam here and one beam here. that would be ideal. However, if that doesn't work and you have to put in another beam somewhere in here and another one over here, well, there's no actual wall to support it on, so you'd have to put another post on this end for our beam, just to get that extra beam in there. All right, so what happens if you decide you want these things to go, our beams to go left and right? Well, again, you got to have 15.6. So from here to the first one, it would have to be less than 15.6. Ideally, we would like to see this span, distance from here to here. If our beam runs this way, that means from here to here, it's got to be less than 15.6, and less than this is 15.6. And so, ultimately, we would have to have a beam here also, because there's nothing supporting this underneath. There's no foundation wall here. So you would need a beam here and a beam here, and then of course you would just continue it on to keep going. The problem you may run into is that it might run through here, and this span from here to here might be more than 15.6. So you may have to configure that slightly different. The moral of this whole story is that you have to have a span of 15.6 or less. If not, you require another beam. So hopefully you can get one here, and you can get one here, and that spans at 15.6. That might work because the distance from here to here is 13.6. So if you got an extra couple feet, you may get away with one beam that runs here and one beam that runs here, but you'd have to mathematically calculate it. Now, in placing the posts, the maximum span of the post is 8.6. Now, of course, in a real design, you'd have to mathematically calculate that, but we're using a 3 2x12 built-up beam, and I know that 8.6 is relatively within the realm of what that can handle, so we're going to stick with 8.6. Now, ultimately, we want that to be equal. So let's say, for example, we get the beam to run front to back. So you'd have to take this distance and calculate that and divide it so it's actually less than 8.6. You wouldn't want to have 8.6, 8.6, and then have a span here of 5 feet. You would actually mathematically calculate it so that this might be, let's say, 6'5", 6'5", and 6'5". So they're even. All right, and the same thing would happen on all the other posts. You want the total distance to be evenly distributed, so the distance between the posts are the same. So keep those things into mind. The big thing, we're using a tripled up 2x12 beam. The biggest span for our 9.5-inch I-joist is 15.6. The biggest span for our beam is going to be 8.6, and you can make the joist run front to back or left to right. So good luck. Do a little bit of math, do some calculations, and see what you come up with.
All right, well, thanks for watching another video. Remember, life's about what you can do, and it's based on what you know. So learn something so you can do something. If you like the content here on Design, Build, and Fix, make sure you subscribe to the channel. All right, we'll see you on the next one.